Hi, I'm gonna show you how to do the first run example with Coreform Cubit and the free open source CalculiX component. So what's the first run example? Basically, you can find it on Github for the Cubit-CalculiX component under the example section. That's our first run component. If you just want to rerun it, just go to the journal file, copy paste the journal, open Cubit, and the journal editor, and just copy paste it in here. That's it. Press the play button and you already have recreated the example. Okay. If you don't want to open the journal editor, no problem at all. Just reset here, just copy paste, and Qubit is doing the job for us. So we will start from new. Okay. First we will need to create some geometry. So in this case we will create a brick. Then as we want to export this as an element set, we will have to create a block in Qubit. So we just create the block. We don't have a specific name, so we just add the volume to it. So next thing, we can add some node sets for the and for the tip. So we will set the name here for, well, let's call it x0. We choose the surface. Then we will do this again for the tip. Now we will see two new node sets and the element set in our model tree. Okay, we don't need side sets for this example, but we need a material. So just call it something like steel. Okay, what do we need? We need the elastic card. And basically we only need the elastic card. So the material is set. Then we need to define a section. It's block ID 1, material ID 1. Okay, we can also just say when we have more blocks than one, all blocks have the same material. This would work too. Now we defined our sections. Okay. How do we apply the load? We will apply the load with a rigid body constraint or a reference point at the tip. So to set the reference point in CalculiX, you basically need two nodes. One for the displacements in the normal coordinate system, and the other thing are for the rotational doves. So how are we going to make a new node here? We just create the vertex. In Qubit, you can create the vertex by a new vertex by picking. Let's say here on the curve. Or you just choose a location. this case we want the center of the surface. So we say it's a vertex on the surface with the surface ID at the center. We can preview the new vertex, and we will have to do this 2 times. Okay. Next thing, we can already create the constraint. So what are we going to connect? We need a node set ID. That's our tip. So it's node set ID 2. We need our 2 vertices, 9 and 10. And we have set the rigid body constraint. So to view some results, we need the output for them. So the next thing is to create the field and history output. We will start with the field output. So which type are we needing? We want some output for the node results, and we also want some output for the element results. So in this case, we create first the output name. And also one for the element output. So now we haven't chosen any key to them. But we will do that next. Just have to click on modify and choose your output keys. So we will probably want to see the displacements and maybe the reaction forces. So which element outputs do we need? We choose here to modify element output with the ID 2. We want to know the strains and we want to know the stress. Okay. So maybe at this point we say, oh, the integration point results would be interesting too. For this we want to use the history outputs that will create the data file later. So again, we go here with a node output and an element output. For the data file results, we always have to choose on which node set or block ID this will work. So in this case we want a node set 3, but we don't have a node set 3 because we haven't assigned any load or boundary condition yet. So let's first create the force on the tip. We choose a vertex. In our case, we choose the reference points as we want force that's aligned alongside the coordinate system. We choose the reference point 9, vertex 9. We can put in a force value. We can choose the direction with a vector. So we want a force that's pointing downwards, and we hit apply. So now we have here a force, and the force has created a new node set. Now we will fix the doves here on this surface. So we have to create a boundary condition, displacement boundary condition. We choose our node set 1. And we will fix them all. Okay. Now we got here our displacement boundary condition. Okay, back to the history output. We can now modify the history output for the node set 3. This is our reference point, so we want to know the displacement and we want to know the reaction forces given. But let's click it. Okay. To get our integration point results, we have to assign the element set. This is our block ID. We only got one block. And we want the results for the strains and the stresses. Okay. Now the next thing is we have to create a new step. Just make a new static step. This will only create the step and we have to modify it again to choose our parameters. So first the general parameter, we want to use the nonlinear geometry. And for the static parameters, for the special step parameters, okay, we will start with the time 0. We have an initial time increment, let's say 0.1. The overall step time is 1. We can choose a minimum increment. We can choose a maximum increment. And those are later for CFD calculations. Okay. So this is set. Now we have to assign the loads and boundary conditions and the outputs to the step. For this we can use the steps management. Basically we only have one step, we want to choose everything, so we can either double click them to assign them or just use the arrow buttons. We hit apply, or in this case okay, just the same, and we are set. Next thing is we want to run CalculiX, so we have to create a new job. Let's call it first run. Basically, if we run the job now, this will throw us an error because we haven't meshed anything yet. But let's try it. So we just hit run and oh, can't run the job. Okay, so how do we mesh this? We can either just click on the volume here and press mesh, or we just write into the command line here mesh vol 1 for all. Okay, now we have meshed the volume, but don't forget to mesh the vertices. So now we have meshed everything. To set the element type for CalculiX, we can first set the element type for Cubit. So we can either just choose the element type for the block here. So we have hexes, so we can, for example, choose a hex 20, or basically this is a hex 8, so a linear element. We will now choose a hex 20, apply it, forgot the ID. So now we have quadratic elements. The standard would be fully integrated quadratic hex element in CalculiX. We can change that too. And just take the reduced. Okay, now everything is meshed and we can run the job. When the job is finished, it will automatically be converted to a peer review format. So it's finished, it's reading the results. Okay, and it's already converted. So let's just look here. Okay, we've got 10 steps. And overall, we can also query our results right here. If we want to, the same for the dot results. So we could already know the displacement of the tip or the force. Okay, now let's view this in pair view. We can also view our sets that we have defined in Qubit with the multi-block inspector. So this is our element set. These are the single node sets. That isn't exported into the FRD file, so we can't show it. But those is the dot file, and those are the integration point results. Okay. So let's just view the displacement. We can choose here which direction we want to view. We can also apply the displacement so that we can view the bending of the beam. We could, yeah, can also view this. So we don't want to view anything here. Let's just select the wireframe. Yep, that looks good. We will now select the displacements here. We will scale that back to 1. Hit apply. Run it again. Yeah, colorful pictures. I like that. Okay. So what can we still do when you want to show the boundary conditions that are set? You can, for example, just draw them. You can also draw the loads. If you click the refresh button, they are gone again. And you can just draw them all. Oh, just don't need the queue at all. Okay. Well, that basically was the first run example. If you want to save what you were doing, just copy paste the history. So if you start from new, you can save that in a journal file or a text file and play that basically again. Okay, thanks for watching.